Hello and welcome everybody to another episode of Books and Bytes. Today, we're taking a deep dive into Isaac Newton's groundbreaking work, Philosophiæ Naturalis Principia Mathematica,
Oh, wow.
published in 1687. It's a dense read,
To say the least.
but don't worry, we're here to break it down for you.
That's right. We're going to try to distill the essence of this monumental work, which is essentially a blueprint for understanding how the universe works. On a physical level.
So think of this as your cheat sheet to understanding Newton's universe. We'll be focusing on the main text itself, leaving aside any prefaces or introductions,
Yeah.
just pure Newtonian goodness.
And there's a lot of ground to cover. We'll be exploring his famous laws of motion, his revolutionary law of universal gravitation, and even touch on some of the mathematical tools he uses to support his argument.
Exactly. So imagine you're sitting down with Newton himself, ready to have your mind blown by his incredible insights, ready to dive in.
Let's do it.
All right, so the book kicks off with Newton laying out some fundamental definitions, almost like he's setting the stage for his grand performance. He defines things like quantity of matter, quantity of motion, and inherent force of matter, terms we might take for granted today, but back then. These are brand new ways of thinking about the physical world.
It's like he's building a new language to describe the universe. And you know what's interesting? Even today, some of these definitions are still debated by physicists.
Really? I had no idea. Okay, so after setting the stage with his definitions, he dives into the main attraction, the three laws of motion. Have you ever wondered why a ball keeps rolling until something stops it, or why it's harder to push a car than a shopping cart?
That's where Newton's laws come in. His first law, often called the law of inertia, says that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction, unless acted upon by an unbalanced force.
So that ball keeps rolling because nothing's stopping it, and the car is harder to push because it has more mass, therefore more inertia.
Exactly. Then comes the second law, which describes how forces actually change the motion of an object. This is where we get the famous equation FMA, or force equals mass times acceleration.
Okay, so the more force you apply to an object, the faster it will accelerate. And the more massive an object is, the more force you need to apply to get it moving.
Right. And this law is incredibly powerful because it lets you calculate and predict how objects will move under the influence of forces.
And finally, the third law. For every action, there is an equal and opposite reaction. I always think of jumping on a trampoline for this one.
That's a perfect example. You push down on the trampoline, and the trampoline pushes back up on you with an equal force, sending you flying. Newton even demonstrated this with magnets, showing that the attractive force between a magnet and a piece of iron creates a balanced system where neither object moves.
So these three laws are kind of like the bedrock of classical mechanics, right?
Absolutely. They explain everything from the motion of planets to the trajectory of a baseball.
But Newton doesn't stop there. He then uses these laws as a springboard to explore some truly mind-blowing concepts, like the nature of centripetal force, which keeps objects moving in a circular path.
That's right. He delves into how objects can move in not only circular, but also elliptical, parabolic, and hyperbolic paths under the influence of an inverse square law force, like gravity.
I remember reading this section and being amazed by how he uses these geometric shapes to describe the movement of celestial bodies. It's almost like he's drawing the blueprints for the universe.
And that's exactly what he's doing. He's taking these fundamental laws of motion and applying them to understand the grand dance of the planets and stars.
This is where things start to get really cosmic, right? He then introduces his law of universal gravitation, the idea that every object in the universe attracts every other object with a force. That is directly proportional to the product of their masses, and inversely proportional to the square of the distance between them.
It's such an elegant and powerful idea. And it explains so much, from why apples fall from trees to why the moon orbits the Earth.
This is where the famous line, "I deduced that the forces which keep the planets in their orbs must be reciprocally as the squares of their distances from the centers about which they revolve," comes from, right?
Yes! It perfectly encapsulates his groundbreaking discovery that the same force responsible for an apple falling to the ground also governs the motion of celestial bodies.
It's truly remarkable. So he's essentially saying that the universe operates on a set of universal laws that apply everywhere, from the smallest particles to the largest stars.
Exactly. And he backs up all of this with rigorous mathematical proofs and geometric constructions.
Now that's where I start to get a little lost.
Mm.
But even if you don't fully grasp the math, The sheer ambition and scope of his thinking is awe-inspiring.
It really is. He doesn't just observe the world around him. He seeks to understand the underlying principles that govern it.
And this is just the beginning. There's so much more to explore in the Principia, from his work on the motion of the moon to his analysis of the precession of the equinoxes.
We'll be back after a short break to delve deeper into these fascinating topics. Welcome back. Before the break, we were discussing how Newton uses his law of universal gravitation to explain the motion of planets and other celestial bodies.
Yes. It's fascinating how he meticulously applies this law to analyze specific phenomena, like the motion of the moon.
He doesn't just say, hey, gravity affects the moon too. He dives into the nitty-gritty details, explaining things like the moon's acceleration, its varying speed in its orbit, and even the regression of its nodes, which is a fancy way of describing how its orbital plane wobbles over time.
And he explains all of this using the same principles he laid out in the first part of the book, right? The laws of motion, the inverse square law, all of that coming together to paint this intricate picture of the moon's dance around the Earth.
Exactly. And it's not just about the moon. He tackles the precession of the equinoxes, which is this slow wobble in the Earth's rotational axis. Can you imagine trying to figure that out using just math and observations?
It boggles the mind. He determined that this wobble is caused by the gravitational forces of the sun and moon pulling on the Earth. It really shows how deeply interconnected everything is in the universe.
And speaking of interconnectedness, Newton doesn't shy away from tackling more earthly matters either. He dedicates a significant portion of the Principia to exploring the motion of fluids.
So we're talking about things like water, air, even things like honey or molasses.
Precisely. He investigates how fluids resist the movement of objects passing through them. Think about how much harder it is to walk through water than through air.
Or how a smooth aerodynamic car slips through the air more easily than a boxy truck. Is that what Newton was getting at?
Yes. He was laying the groundwork for understanding concepts like drag and viscosity, which are crucial in fields like engineering and aerodynamics.
It's incredible how he was able to apply these fundamental principles to such a wide range of phenomena. Did he stop at fluids? Or did he have even more areas he wanted to explore?
Oh, he wasn't done yet. He even delves into the nature of sound and light.
Now, wait a minute. Wasn't this book supposed to be about motion and gravity? How did light and sound fit into all of this?
Remember how he defined motion at the beginning? Well, he saw sound and light as forms of motion as well, waves propagating through different mediums. He even theorized that light was made up of tiny particles, which was a pretty revolutionary idea at the time.
It's like his mind was constantly searching for the underlying connections that unify seemingly disparate phenomena.
That's a great way to put it. He was weaving together different strands of physics, mechanics, optics, and even what we might today call astronomy to create this grand tapestry of knowledge.
So we've talked about his laws of motion, his law of universal gravitation, his work on fluid, sound, and light. But what are some of the lasting impacts of this book? Why is it still considered so important centuries later?
One of the most significant impacts is that Newton essentially laid the groundwork for what we call classical mechanics, the branch of physics that deals with the motion of objects. His laws and principles are still used today to design bridges, buildings, airplanes, and even spacecraft.
So while his theories have been expanded upon and refined over the centuries, they still form the basis for much of our understanding of how the physical world works.
Exactly. And beyond the practical applications, his work had a profound impact on the way we approach science itself. He emphasized the importance of observation, experimentation, and mathematical rigor in understanding the universe. He showed that the universe wasn't some mystical, unknowable entity, but rather a system governed by laws that we could uncover and understand.
It must have been a radical idea at the time.
It was a complete paradigm shift, and this shift paved the way for the scientific revolution and the incredible advancements in our understanding of the world that followed.
Now, I know we've been focusing on the main text of the Principia, but there is one section I'd love to touch on before we wrap up this deep dive. It's the section titled Rules of Reasoning in Philosophy.
Ah, yes. This is where Newton lays out his philosophical approach to scientific inquiry.
He essentially sets forth some guidelines for how we should approach the study of nature. It's fascinating to see how he emphasizes simplicity and elegance in scientific explanations. He argues that we shouldn't invent unnecessary complexities when simpler explanations suffice.
This is a key element of his scientific legacy. His famous phrase, "Nature does nothing in vain, and more is in vain when less will serve," encapsulates his belief that nature operates according to simple, elegant principles.
A powerful reminder that sometimes the most profound truths are also the most elegant. It's like a call for clarity and conciseness in scientific thinking.
Exactly. He was urging future scientists to seek out the most parsimonious explanations, to shave away unnecessary complexities, and to find the underlying beauty and simplicity in the laws that govern the universe.
It's an approach that continues to inspire scientists today. So after exploring the depths of the Principia, what's the one big takeaway you would leave our listeners with?
I think the biggest takeaway is the sheer scope of Newton's ambition. He wasn't content to just observe the world around him. He wanted to understand the fundamental principles that govern it, from the smallest particles to the largest celestial bodies. And in doing so, he provided a framework for understanding the universe that has shaped scientific thought for centuries.
It's truly a monumental work, one that continues to inspire awe and wonder even today.
Absolutely. And while Newton's work was a giant leap forward, it was just one step in a much longer journey of scientific discovery.
And on that note, we'll be back in a moment to finish up our exploration of Newton's remarkable work and its enduring legacy. Welcome back to Books and Bytes. We've been on quite a journey through Isaac Newton's Principia, exploring his laws of motion, his groundbreaking law of universal gravitation, and his forays into the world of fluids, and even light and sound.
It's remarkable how he managed to connect so many different aspects of the physical world under one unified framework.
As we've been discussing Newton's work, I've been thinking about how his book wasn't just a collection of scientific discoveries, but also a testament to a particular way of thinking. He approached the study of nature with this incredible blend of observation, mathematical reasoning, and a constant search for underlying principles.
That's right. He wasn't satisfied with just describing what he saw. He wanted to understand the why behind it all, the fundamental laws that govern the behavior of the universe.
And that's what makes the Principia such a landmark achievement, right? It's not just about the specific discoveries, but about the methodology, the approach to scientific inquiry that he championed.
Absolutely. He set a new standard for scientific rigor, combining meticulous observations with powerful mathematical tools to create a system of knowledge that was both elegant and remarkably accurate.
It's like he was saying, look, the universe isn't some random chaotic mess. There's order, there's logic, and we can use our minds to figure it out.
And that idea, that the universe is comprehensible through reason and observation, was revolutionary. It helped spark the scientific revolution and paved the way for centuries of incredible discoveries.
So as we wrap up this deep dive into the Principia, what are some of the key takeaways you want to leave our listeners with? What's the enduring legacy of this book?
Well, as we've discussed, Newton's work provided the foundation for classical mechanics, which is still used today in countless fields, from engineering to astronomy. But beyond that, his emphasis on observation, experimentation, and mathematical reasoning continues to shape the way we approach science.
It's like he gave us a toolkit for understanding the universe, a set of principles and methods that continue to guide scientific inquiry to this day.
Exactly. And while we know now that his theories don't explain everything, we've got things like relativity and quantum mechanics to account for the very large and very small scales of the universe. His work remains an incredible testament to the power of human curiosity and the ability of our minds to unravel the mysteries of the world around us.
It's inspiring to think about how one person, armed with a pen, paper, and a brilliant mind, could reshape our understanding of the cosmos so profoundly.
It really is. The Principia is a reminder that even the most complex phenomena can often be broken down into simpler, more fundamental principles. And it's a testament to the power of human ingenuity to unlock the secrets of the universe.
Beautifully said. Well, I think we've covered a lot of ground today. From the basic laws of motion to the intricate dance of celestial bodies, we've explored the key ideas that make Newton's Principia such a groundbreaking work.
It's been a fascinating journey, and I hope our listeners have gained a deeper appreciation for not only the brilliance of Newton's insights, but also the enduring power of his scientific approach.
Absolutely. So to our listeners out there, if you're ever feeling overwhelmed by the complexity of the world, remember the lessons of the Principia. Look for the underlying patterns, embrace the power of observation and reasoning, and never stop questioning the why behind the things you see.
That's a great message to end on. There's always more to explore, more to understand, and more to discover.
Thanks for joining us on Books and Bytes. We'll see you next time.